1, 2, 3, 4, 5, 5. That gives you the mean, right? So mean is the sum of digits divided by the number of what? Digits. Or the sum of variables divided by the number of variables. That is what mean is the average of a set of numbers or values or variables. So variance is the mean, which is the average. Mean of what? The mean of squares of deviations. So for you to understand better what variance is, we start with the mean of deviation. You know, when we say something has deviated, means that it has gone out of normal. Is now abnormal. It has left the normalcy and then becomes an abnormal. Just like now, I'm standing here now. So if I leave, you are deviated from this point. So deviation in this context, deviation is the subtraction of the mean value from each of the given values. In this context now, deviation is the difference obtained when you subtract the mean value.
But can you write it?
Okay. So deviation. Let me say in this context, deviation is the difference obtained when the mean value is subtracted from each value in a given distribution. So in this context, deviation is the difference obtained when the mean value is subtracted from each value in a given what? Distribution. Distribution is simply a set of values listed. That's what distribution is. A set of values listed. Let's take for instance now. I said that variance is the mean of the squares of deviations from their mean values. That means we can get the deviations of a set of values from their mean value by what? By subtraction. Are you there? So let's take for instance now. For instance, if you ask to find the deviations of each value in the distribution 3, 6, 5, 4, and 7. Look at this now. Find the deviations of each value in the distribution. It means subtract the mean of this set of values from each of them.
I have to calculate mean first.
So you have to calculate mean first, correct. So you have to get the mean of this set of values of this distribution. So that is, you now say solution, and I say mean equal to sum of what? Digits given, right? Over number of what? Digits, which is 3 plus 6 plus 5 plus 4 plus 7 over what? 5, right? So which will give us 3 plus 6 is what? 9. 9 plus 5, 14. 14 plus 4, 18. 18 plus 7, 20 over what? 5 equal to what? 5. So 5 is the what? Mean, right? So to find the deviation of each of these values, then we have to subtract the mean from each of them. Yeah, we can do that in tabular form. Let's quickly do that in tabular form. You know, I'm talking about mean. I'll still come back to deviation, variance. I'm talking about deviation. I'm talking about deviation. I'll still come back to variance. By the time we're done with deviation. Now, to get the deviation now, we can do that in tabular form. We have x minus x bar. Now this sign is called absolute value. This sign like this is called absolute value. We call it absolute value. Absolute value sign is used to change a negative number to positive. For example, if I have something like this, is equal to 2. Yeah? And is by the time this negative value leaves this place, it's going to become a positive. By the time this negative value leaves this environment, it's going to become a positive value. What if it's a positive value? It still be a positive value. It will still remain as a positive value. So this sign is used to change negative value to positive. This symbol. So what are the values of x? You know, the values of x are 3, 6, 5, 4, and 1. 7, right? So this is absolute value 3 minus, what's that mean? 5, right? Which will give you minus 2. Equal to what? 2. So I can remove the absolute value. Then this one is going to be 6 minus 5, which is equal to 1. Equal to 1. Then this one is 5 minus 5, which is equal to what? 0, right? Which is equal to 0. Then this one is 4 minus 5, which is equal to minus 1, equal to 1. And then finally, 7 minus 5, which is equal to 2, right? Which is 2. So the deviations are what? 2, 1, 0, 1, right?
1, 2.
And what? 2. So that is 2.
That negative 2 and negative 1. Is it because of our absolute?
Yes, the absolute value. We introduce that.
You don't count minus 3.
No, we introduce absolute value to change the negative sign. To change negative value to positive. Alright. So 2 is said to be the deviation of what? 3. 1 is the division of what? 6. 0 is the division of what? 5. So deviation, like I said earlier, in this context that we are discussing, is the difference obtained when the mean value is subtracted from each value in the word, given word distribution. So this is what called deviation. These values we got here are called deviations. Is that understood? Now, when I square these deviations, let me square them now. What's the first one here? Now, when I find the mean of the word squares, the mean of the word squares of deviations, right? To find the mean of the squares of deviation means to add these, to square these deviations and add them together, and then divide them by how many they are, right? So that is 2 square, right? Plus 1 square, right? Plus 0 square, right? Plus 1 square, plus 2 square. What am I doing? I'm finding the what? Mean of what? Squares of what? Deviation. So these are the deviations. Then I'm squaring each of them and then adding them together. Divided by how many they are, which is what? 5. Are you there? Whatever it gives me is my what? Variance. So variance is the mean, according to what that definition, is the mean of what? The squares of deviations from their main value. So the squares, look up there, the mean of the squares, mean, of course, like I said earlier, the mean is a summation of values divided by the number of values. The summation of values divided by the number of the values. So look at the values here, 2, 1, 1, 2. The summation of these values divided by divided by how many these values are, or divided by how many they are, is the mean. So the mean of squares, not just that I'm trying to add up the values and divide by how many they are, I'm also squaring them before adding them together. So the mean of the squares of divisions is, so what are the divisions? 2, 1, 0, 1, 2, right? So I have to square them and divide by the number of deviations I have here. So that will give me 4 plus 1 plus 0 plus 1 plus 4, right? Over what? 5. So adding these together, 5, 6, 10. 10 over what? 5, which is equal to what? 2. So my variance is what? 2. Therefore, the variance is equal to what? 2. Do you understand what variance is now? So what the symbol for variance is this. Look at the symbol here. This. So you can now say, I can just leave this and write and put the symbol. Therefore, the variance is 2.
That's symbol square.
Yeah, this is symbol for variance.
That square is what?
It's a symbol. These are the symbol for variance. Why, if you don't put the square, it's a symbol for standard deviation. That's the next thing we'll talk about now. So after variance, the next thing is what? Standard deviation. Standard deviation. I said that we'll talk about 2 things before we move to truncated distribution. Now, what is standard deviation? Standard deviation is the square root of variance. Look at it here. Look at the definition. Standard deviation is the square root of variance. Are you false? Standard deviation is the square root of variance.
Yes.
So that means if I want to find the standard deviation, I have to find the square root of this. And I say to find this same is what? To find standard deviation. Then I have standard deviation is equal to square root of what? Variance, right? Which is equal to square root of 2, which we got here, right? Square root of 2 equals 1.414. It equals 1.4142. And so on. If you punch your calculator, it will be. So this is the standard deviation. Now, the symbol for standard deviation is this symbol. So you can say standard deviation equal to square root. You see that, right? Of variance. So I can just click this and just put the symbol. Therefore, my standard deviation is 1.4142. So standard deviation is square root of. Now it has a formula. It has a formula. I'm not doing this. Should I click here? The formula for variance is given as, look at the formula here. This symbol means summation. Summation. That's what this symbol means, which is addition now. Yeah? Summation of x minus x bar squared. You remember this formula, right? X minus x bar deviation over n, where n means the number of what? X involved. That's the number of values involved in the distribution or in the set of values given. Are you there? Then this x bar is the what? Mean, right? Where x
see that is a number means summation.
Okay, where this means summation. Means summation. Then x is the variable, is the random variable. Random variable. Now I want to say something is a random variable is a variable whose values alternate, changes. That means if the values, it does not represent only one value. The value changes. Just like x is 3, 6, 5, 4. So if the value changes, it's not just a particular value. So we call it a random variable. Then our x bar is the mean or average. The average value. Then n, I've defined everything we have in the formula. N is what? Number of values involved in the distribution. Number of values involved in distribution represented by a variable x, which is the random variable. Then this symbol, of course, you know now, is the symbol for variance. So the formula we have on the board is the formula for calculating what? But if I apply this formula, I'll still get 2 as my answer. I'll still get what? As my what? Answer. Look at it here. Summation, right? Summation means addition. So we have bar x. The first x is what? 3, right?
Addition of
addition of the deviations now. Then don't forget that you have to square each of the deviations. Look up, that is 3 minus 5 square. Where x is what? 3. X bar is what? 5. Plus 6 minus 5 square. Where x is 6. X bar is 5. Plus the next value for the random variable is what? 5. 5 minus 5 square plus, let's be fast, 4 minus 5 square plus 7 minus 5 square over, my n is what? Number of values involved in the distribution represented by a variable, right? So how many? We have 5 values. So if you do that, that will give us
no wonder this is the reason why you changed to positive.
0 square minus 1 square 2 square over 5, which is equal to minus 2. If you open it, that will be what? Are you there? That will be 2 square, right? Because if you open this, if you remove this absolute value sign, the negative integer changes to what? Positive, right? Plus 1 square plus 0 square plus 1 square plus 4 square, which is equal all over what? 5. And everything will still give you what? 2. Alright, so that now this formula is applied. This formula is applied when frequency is not involved. When frequency is not involved, that's when you apply this formula. When frequency is not involved. Because then you might be in a situation whereby 3 will occur more than once. If 3 occur more than once, let's say for instance like f. Next percentage value is 3, 6, 5, 4, 7. And then down here we have f means frequency. Let's say f2. That means that 3 occur twice in the distribution, which is 3, 3. Then here we have 4. Means that 6 occurred 4 times. 1, 2, 3, 4. Then here, let's say 3. Means that 5 occurred 3 times. And then here, let's say 1. That means 4 occurred just once. And then here, let's say 5. Means that 7 occurred 5 times. 1, 2, 3, 4, 5. You see that the random variables, the values have what? Frequencies, right? So they occurred more than they have frequencies. Frequency is the number of occurrence of an event or of a value. So if the situation involves frequency, then the formula will change. The formula will be, let me write it here. Now, if it has, I'll clean this, right? Yeah, right? So if it involves frequency, then the formula will now be variance equal to summation of f absolute value x minus x bar squared over summation of f. Look at it here. That's if it involves frequency. So you apply this one when it involves frequency. So this is applied when frequencies are involved. When it involves frequency, you apply this. Do you understand that now? Okay, let's use this now. Let's use this. Say example 1. Find the variance. Then given the values you have in the table. So you can apply this and now say solution. Summation of f, right? That means summation of f. Well, if you have it like this, for instance now, it means summation of f times x. That means you are multiplying the frequency by the scores or by the values given. Are you there? You are multiplying the frequency by the corresponding value of x. So what's the corresponding value of this frequency? Is 3, right? What's the corresponding value of this frequency? 6. So I want to say I'll start f, which is 2. 2 times absolute value. What is my x? 3, right? 3 minus what? 5, right? My mean is 5 now. Square, right? Summation is plus f again, which is the next number, 4 times absolute value. What's my x? 6, right? Minus 5 square. Plus f again, which is the next frequency. 3 times absolute value. What's my x? 5 minus 5 square. Are you there? Plus then f again, which is the next frequency. 1 times absolute value x. F is what? 4 minus 5 square plus. Are you following? Then lastly, my f is what? 5, which is the last frequency, times absolute value x is what? 7 minus 5, I mean is 5 square over, then no longer n again, because n is when frequency is not involved. Are you there? So, but when frequency is involved, it's no longer n, it becomes summation of f. The summation of this frequency. That is 2 plus f, this same summation of this frequency, 2 plus 4 plus what? 3 plus 1 plus 5. So by the time you compute everything, whatever it gives you is your what? Variance. And how do you compute that? I'll just use one. That is 2 times absolute value minus 1, 2 square, right? So by the time you do this, it's going to be 2 times, open this, that is 2, which is 2 times what? 4, right? equal to what?
8.
So that means all of this thing is what? 8. Plus, I'll now do this one too. Do this one too. Do this one too. Do this one. Then add together and divide that. I give you a point now. Alright. So this formula is for variance when frequency is involved. Why this one is for variance when frequency is not what? Involved. So based on what you have just said now, that means standard deviation now will now be what? If you want to put the formula for standard, if you want to write down the formula for standard deviation, since standard deviation is a square root of variance, so it's going to be standard deviation equal to now square root. If you are writing the formula now, you now put this inside. Summation of what? S minus what? S bar square over what? N. So you apply this formula to calculate what? The standard what? Deviation when frequency is not what? Involved. This one is the formula for standard deviation when frequency is not involved. This one now. But when frequency is involved, it's going to be standard deviation equal to what? Square root. Put this now inside. Summation of what? F. Absolute value x minus what? X bar what? Square. All over summation of what? F. Am I right? So this one is applied where frequency is what? Involved. In finding what? Standard what? Deviation. This is the formula for standard deviation when frequency is involved. Do you get the point now? Alright, so here comes truncated distribution that we have been waiting for. Alright.